In this tutorial, we're going to talk about angles and parallel lines. So the first postulate we're going to talk about is called corresponding angles, and we're going to go ahead and draw a picture of this. So we're going to go ahead and draw some parallel lines which look like this. So there's one, and then another one that doesn't intersect. So there we go. And then what we're going to do is we're going to make a line that goes straight through both of these, and this line has a very special name. This is called a transversal. And what you're going to be able to see as well in your pictures is that they're going to have these little arrows on the lines that are parallel, so you know which ones are which. Just like so. So what we're going to do is we're going to go ahead and we're going to label all the different pairs of corresponding angles that we have in this picture. So corresponding angles have a couple characteristics, which are that they're going to be on the same side of the transversal, and one angle is on the outside of the parallel lines and the other is on the inside. For example, I'm going to use blue here, and here would be one angle that's on the outside of those parallel lines and on that side of the transversal. So I'm going to find the other one that's on the inside of those parallel lines, also on the same side of the transversal, and that's going to be right here. So I'm going to go ahead and label a couple other pairs that we have. So I could start right here in green as well. So the other one on the same side of that transversal would be right here. And I could do this again. I'm going to do this one right here. I'm going to start on the inside this time in orange, and its corresponding angle is going to be over here on the outside. And the last one that we have are obviously the ones that we haven't labeled yet. So this one here and this one here. So those are all the different kinds of corresponding angles that you can have, and they all have a very unique property in that all corresponding angles are congruent. So let's go ahead and talk about the next one. This is going to be alternate interior angles. And when we talk about the word alternate, that's talking about the opposite side of the transversal. And the interior part means that they're going to be on the inside of the parallel lines. So let's draw ourselves a picture, just like that. And notice again that we've got these arrows right here, and that means that those are the lines that are parallel. The other line is called the transversal, the one that intersects both of them. So we're going to go ahead and find a couple pairs of alternate interior angles. So I'm going to go ahead and start on the inside of my parallel lines. I'm going to start right here, and I have to go on the opposite side of the transversal but stay within my parallel lines. So that would be right here. They're not going to be side by side. They've got to be on the different parts. So one has to touch one parallel line, the other has to touch the other. So that's one kind of parallel or alternate interior angles. So let's go ahead and find another pair. There's actually only one other pair in here. So if I start here in yellow, the other guy would be right down here. And what's really cool about the alternate interior angles, which we can abbreviate as AIA, is that all pairs of alternate interior angles are always congruent, which is very useful. So let's talk about the next one. And the next one's called the consecutive interior angles theorem. And when we say the word consecutive, it means it's on the same side of the transversal, and the interior means the same one as above. They need to be on the inside of the parallel lines. So I'm going to get my picture drawn. So I'm going to go ahead and pick my first angle, which is right here in blue. And the other angle has to touch the other parallel line, but it also has to be on the inside of the parallel lines and on the same side of the transversal. So that would be right here. My other pair of these guys would just be on the other side of that transversal, here and here in yellow. And we can go ahead and abbreviate these guys as consecutive interior angles. Oh, it's the CIA. And these angles have a special property as well, in that these are supplementary. So every single pair of consecutive interior angles will always add up to 180 degrees. So the next one is called the alternate exterior angles theorem. And the alternate part means it's opposite sides of the transversal, and exterior means that the angles have to be on the outside of the parallel lines. So let's draw our picture. So I'm going to go ahead and start my angle up here in this pinkish color. So I'm going to find another angle on the opposite side of that transversal, but also on the other part of the outside of those parallel lines, which would be right here. Okay, so that's an example of alternate exterior angles. Another example of that would be if I were to start right here in orange and then find its match over here on its alternate exterior side. And these also have a special property. Alternate exterior angles, we can abbreviate those like this. And alternate exterior angles are always going to be congruent. Now, we do have one more special pair of angles that exist, but it's not covered in our textbook, and I just want to make sure that we go over it just in case. So these ones are called consecutive exterior angles, and of course the consecutive part means that they're on the same side of our transversal, and the exterior part means that they're on the outside of the parallel lines. So just briefly, I'm going to show you what that picture would look like. So here's our parallel lines, and I'm just going to do this quickly. And here's our transversal. So same side exterior angles. So I'm going to pick this angle right here because it's one angle on the outside of that parallel line. I'm going to find the other one that's on the same side of the transversal on the outside of the other parallel line, which would be about right here. So there's one pair. There's one other pair that exists, and that's going to be right here and right here, don't you know? Okay, now the special quality that consecutive exterior angles have is that these are also supplementary. They also add up to 180 degrees. So these are all the different kinds of special angles that we have. So let's take a look at a quick example. So here's our first example, and of course we have a couple pairs one pair of parallel lines and a transversal, and this question is going to be for us to solve for the missing variables, in other words, the missing angles. So we're going to practice some of the different kinds of angles that we just saw, and what we're going to do first is make sure we know where our beginning angle is that we're given. So I know that this guy right here is 55 degrees. I also know that these two angles right here, x and that 55, create a linear pair. In other words, they make a straight line together. And that means that those two angles are supplementary. Now, these two angles are not one of the special kinds that we just talked about, but that is one of the ways that we have to use this to solve for x. So we're going to go ahead and set up an equation that says x plus 55 equals 180. And so we're going to go ahead and solve this. So we're subtracting both sides by 55. And we're going to come out with 125. Nope, sorry. Yep, never mind, that's right. We've got 125 degrees. So there's my first measure. Okay, so now we get to go on to the next pair. And I'm still going to start with my 55 degrees, and I'm going to see if there's one of those special relationships with 55 degrees and angle Y. So let's first identify where they start on that transversal. So the transversal is right here, and it looks like those angles are on different sides of that transversal. So we're talking about something with something opposite, okay? An alternate exterior or interior case. Okay, and I also know that this angle is on the exterior of this parallel line that it's next to, and 55 is on the outside of the second parallel line. So these are exterior angles. So it's looking like the relationship between the 55 degrees and angle Y is that they are alternate exterior angles. And we have to remember what their special property was, and that is that they're congruent. So I know already that the measure of Y is going to be 55 degrees. And that's how we solve that. Let's take a look at one more. Okay, so here's example 2. So we've got our pair of parallel lines and our transversal, and what's going to happen sometimes in your textbook is they're going to have some expressions for your angles, and it may not always be so clear as to where they belong. Always feel free to ask. This 2x minus 15 is this angle right here, and the x plus 55 is right here. Okay, so we have to identify their relationship first. Now, here's the transversal right here, and it looks like they're on different sides of it, so that's meaning alternate. And it looks as well that both angles are on the insides of our parallel lines, so that means interior. So it looks like we've got a pair of alternate interior angles, and I know that those angles have the relationship in that they are congruent. So I need to set up an equation for these guys, and when I do that, I just set them equal to each other because that's what congruency means. So I set up my equation, which is going to be 2x minus 15 equals x plus 55. So we're going to go ahead and solve this. I'm going to subtract the x from both sides. And I'm going to get 1x minus 15 equals, and these guys canceled, so 55. And lastly, I'm going to add 15 to both sides, sorry. And the 15's cancel, and I have x equals 70. Now, granted, I'm glad that I've got my x value, but I want to go back in and figure out the measure of both those angles. So we're going to do some substitution. So I'm going to do 2x minus 15 here, and I'm going to substitute x with 70 to figure out how big that angle is. So 70 minus 15, and 2 times 70 is 140. We're going to take away 15, and that's going to give me 125 degrees. Now, granted, if I know that these are alternate interior angles, I know already that that other angle, the x plus 55 one, should also end up being 125 degrees because we already said that they're congruent. But just to make sure, just so you can see how to work it out, we are going to go ahead and do substitution for this one as well. So there's the x plus 55. I plug in 70, and sure enough, we add them together and we get 125 degrees. And that's it. And that's going to conclude this tutorial.